The sun does not care about you. It's a ball of nuclear fire about 93 million miles away. It's been burning for roughly 4.5 billion years, and the entire time it has been spraying invisible radiation at this planet without once stopping to ask how anybody down here felt about it. That uncaring star is the single reason human skin comes in every shade it does. Pale, dark, and every tone in between. All of it is the result of one long, slow, weirdly dramatic argument between the human body and a star that was never, ever going to lose. This is the story of how a species that started out wearing one single color got talked into a dozen of them by the weather. And the thing worth knowing before anything else is this: skin color is one of the shallowest facts about a person there is. Not the deepest. The shallowest. It's a handful of genes. It's a coat of paint the sun applied to your ancestors based on where they happen to be standing. Humans have spent most of their history treating it like the bottom of the well. It's the surface of the puddle. Here's the version most of us picked up without anyone ever sitting us down to teach it. Humanity split into branches a long, long time ago. Dark people down where it's hot, pale people up where it's cold, and those branches run deep. Ancient, fixed, separate roots of a very old tree. Skin color as a kind of family badge, proof of where you really come from, stretching back forever. It's a completely reasonable thing to assume. The categories basically hand it to you. And for most of modern history, the people inventing those categories said it out loud with total confidence. Take the guy who handed us the actual word. In 1795, a German anatomist named Johann Friedrich Blumenbach was sitting in Göttingen with a shelf full of human skulls, deciding to sort all of humanity into 5 types. He needed a name for the group he liked best, so he picked up one skull he owned, from a woman who'd lived in the country of Georgia, in the Caucasus Mountains, decided it was the prettiest one on the shelf, and named an entire chunk of humanity after the mountains it came from, Caucasian. Then he ranked everyone else as uglier departures from his favorite skull, and reached for words like degenerate for the ones he liked least. So the word a couple billion people still tick on official forms today started life as one man's opinion about which skull was the most handsome. That's the foundation. 230 years old, built mostly out of a vibe. That crack alone should make you a little suspicious. But it isn't the deep one. The deep one is in the actual ancient bones, the ones nobody got to pick. And they say something nobody in Blumenbach's century could have seen coming. In 2018, a team at London's Natural History Museum, working with University College London, drilled a tiny hole into the densest bone in the human body, a chunk of skull buried deep behind the ear, where DNA hangs on the longest. That bone belonged to the oldest near-complete skeleton ever pulled out of British ground. A man found in a cave in Somerset back in 1903, dead for about 10,000 years. For most of the last century, the museum had shown him as a friendly, pale-skinned model, because obviously an ancient Brit was pale. That was the whole assumption. Pale skin was the original northern factory setting, going back as far as anyone cared to imagine. The DNA said no. Dark skin, the museum slotted it into the 2 darkest of 5 categories, dark to black. And blue eyes, the exact combination almost nobody on Earth carries today. Selena Brace, who runs the ancient DNA work at the museum, and Chris Stringer, who'd spent a decade on the bones from that cave, both landed on the same word for it. Surprising. The man we now call Cheddar Man had skin you'd expect in sub-Saharan Africa, and eyes the color of a cold winter sky. The museum quietly retired its old pale model and built a brand new face straight from his genome. Dark-skinned, blue-eyed, staring out at a country that doesn't look like him anymore. And he wasn't a fluke. The same signature had already shown up in skeletons from Spain, from Luxembourg, from Hungary. The people who walked into Europe after the last ice age were, as a whole, dark-skinned with light eyes, which flips the entire question upside down. Pale European skin, the thing everyone treats as ancient and original, turns out to be one of the youngest things in this whole story. A few thousand years old. Tops. Out of the whole 300,000 years this species has been around, that's the last little sliver. Call it the final 2 or 3% of the book, scribbled in the margin on the last page. So the puzzle was never how some people got dark. Everybody was dark. The real question is how a few populations turned pale that recently, and why the planet bothered to make them. Start with the part that's so total, it's easy to skip right past. Every single human alive descends from dark-skinned ancestors. Not most, all of them. Rewind anybody's family tree far enough, and you hit the same dark-skinned people standing in Africa around 300,000 years ago, when the species first showed up. There were no pale humans. None. Not in the history books, not in the cave paintings, not in a single myth or king or founder anybody can name. The setting hadn't been invented yet. And there's a brutally simple reason dark came first. Somewhere over 1 million years back, around the time of Homo erectus, our ancestors lost most of their body hair, probably to sweat hard and stay cool while chasing food across hot open ground for hours. Humans are, no exaggeration, some of the best sweat-cooled animals nature has ever built. Great upgrade. One catch, bare skin under the equatorial sun, is a sitting duck. Ultraviolet light, the invisible part of sunlight, slams into the DNA inside your cells and snaps it. Enough breakage in the wrong spot turns into mutations, and enough mutations turn into cancer. Melanoma, one of the meanest. So evolution reached for the obvious tool, melanin. The dark pigment in skin is, in the most literal sense possible, built-in sunscreen. Always on, never washes off, never needs reapplying, the original SPF. The more of it you've got, the darker you look, and the less UV punches down into the layer where your cells keep their DNA. So dark skin isn't decoration, it's body armor. In Africa, under some of the hardest sunlight on the planet, evolution selected for that armor hard, fast, and without sentiment. Natural selection doesn't have a vision board. It runs one cold little question over and over. Did this help you have surviving kids? Yes or no? And under that sun, dark skin was a screaming yes every single time. But cancer isn't even the main event. The deeper reason runs through something most people have never heard of. And this is the part where the jokes have to step outside for a minute. There's a molecule in your blood called folate. It's a B vitamin, and in the first few weeks of a pregnancy, it's doing one of the most important jobs in all of biology, helping build the neural tube, the structure that becomes a baby's brain and spinal cord. Run short on folate at that exact moment. And this is usually playing out weeks before anyone realizes a pregnancy has even started. And that structure can fail to close. The results are devastating. Severe birth defects, miscarriage. And here's the cruel hinge of the whole story. Ultraviolet light pouring through skin destroys folate in the blood. So in punishing sun, the lighter the skin, the more folate burns away, and the fewer babies survive. Dark skin was protecting the next generation before the next generation even existed. That's the real engine. Not comfort, not looks. The survival of children. And the fingerprint of that pressure is still readable in living people. A 2018 study found that folate-related gene variants still shift right alongside skin color across the world's populations. The body quietly hedging the same ancient bet. So if dark skin is this all-in-one fix, blocking cancer, guarding pregnancies, why would anybody's ancestors ever trade it away? Because the sun plays both sides. Skin doesn't just block UV, it also runs on it. Your body only makes vitamin D, which builds bone and powers a huge chunk of your immune system, when UV actually hits your skin. Down at the equator, there's so much sun that even very dark skin cranks out plenty. But follow people north, drifting out of Africa somewhere between 70 and 100,000 years ago, up into Europe and Northern Asia. And the math collapses. Up there, the sun is weak and low for half the year. Dark skin, doing its job, blocks so much of the little UV that's left that it can't make enough vitamin D. And vitamin D starvation in a cold place is no small thing. Soft, bending bones, pelvises too narrow to survive childbirth, children who don't make it. Push far enough north, past Scotland, and for months the sun never even climbs high enough to make a single usable ray, no matter how long you stand out in it. So up north, the pressure flipped completely. The very same skin that saved your kids at the equator was now slowly killing them. Lighter skin, letting more of that scarce light slip through, started to win. Here's the test that proves it's really about sunlight, and it's the good kind of strange. If weak sun forces skin to go pale, then the people living in the darkest place on Earth, the high Arctic, should be the palest humans alive. They aren't. The Inuit kept fairly dark skin in a place that barely sees the sun for months. For a long time, that looked like the rule breaking. It's actually the rule winning. They were getting their vitamin D straight off the plate. A diet of fish, seal, and whale is absolutely drowning in the stuff. Dinner did the job the sun couldn't, so their skin never had to change. And that's the same reason the dark-skinned man in the Somerset Cave stayed dark. His people were hunter-gatherers who ate a mountain of oily fish. The folks who actually needed pale skin showed up later. Farmers. When humans switched over to farming around 9,000 years ago, the menu shrank down to grain. Wheat, barley, oats, which has almost no vitamin D in it. All of a sudden, your skin was the only vitamin D factory left running, and if it was still dark, it couldn't keep up. These farmers didn't trickle in quietly either. They rolled across Europe in waves, first farmers spreading out of what's now Turkey, then herders sweeping off the steppe, and each wave repainted the continent a shade lighter, absorbing the dark-skinned hunter-gatherers already living there. And big, crowded farming villages spread a winning gene way faster than scattered bands of 50 people ever could. Diet collapse plus dense crowds slammed the whole process into fast forward. The Pale North isn't the opening scene of this story. It's the leftovers of a couple of migrations that, on the timescale of the species, wrapped up about 10 minutes ago. And when that change finally got written into the code, a shocking amount of it came down to one almost insultingly tiny edit. In 2005, a cancer geneticist named Keith Cheng, over at Penn State, wasn't even studying humans. He was studying a washed-out mutant zebrafish nicknamed Golden. He chased down the gene behind its pale color, went looking for the human version, and found a near-perfect match, a gene called SLC24A5. One letter of it differs between most Africans and most Europeans. 1. That single swapped letter is carried by more than 95% of people of European descent. And on its own, it accounts for somewhere between a quarter and a third of the entire skin color difference between European and African populations. Centuries of treating skin color like a deep, defining canyon. And a giant slice of it comes down to one typo that swept through recently. The hunter-gatherers in those caves, the man in Somerset included, mostly didn't carry the full European set yet. The trait that reads today as the oldest, most settled marker of an entire continent is one of the freshest coats of paint in the building. And here's where the old tree with deep branches idea really falls apart. Europe wasn't the only place that went pale. East Asians have light skin too. And the obvious guess is that light skin is just light skin, one shared inheritance. Nope. When geneticists looked, the European recipe for pale, that SLC24A5 letter and a few teammates, was mostly missing in East Asians, who built their lighter skin out of a totally different set of genes. Same destination, completely different roads, paved separately. Light skin got invented at least twice, on opposite ends of the same landmass, each group quietly solving the same weak sun problem on its own. Biologists call that convergent evolution. And it's about the loudest signal nature ever sends that a trait genuinely matters. When the sun keeps forcing the same answer out of unrelated people, that answer is clearly doing real work. And the two recipes aren't even equally good. The European route comes with a nasty hidden bill. Melanoma, the deadliest skin cancer, runs something like 10 to 20 times higher in Europeans than in Africans. The East Asian route to the same paleness barely lifts that risk at all. Two groups landed on nearly the same shade, and only one of them got handed the brutal receipt, which only makes sense if these were two separate experiments that happened to end up in the same neighborhood, not one shared family heirloom. And eye color pulls almost the same trick, maybe even cleaner. Cheddar Man's blue eyes weren't some random quirk. They point straight at one of the strangest facts in the entire human genome. In 2008, Hans Eiberg, a geneticist at the University of Copenhagen who'd been chasing eye color since the 1990s, worked out that every blue-eyed person alive today, all of them, the whole planet's worth, traces back to one ancestor, one person, one mutation, somewhere up near the Black Sea, roughly 6,000 to 10,000 years ago. Before that human was born, the whole species had brown eyes, brown all the way down, for hundreds of thousands of years. Then, one switch flipped in one body, and it spread. So a trait people treat as ancient and meaningful is younger than farming, younger than the wheel, younger than the oldest city on Earth. Humans keep mistaking the brand new for the primordial. So back up and look at the whole machine. Skin color, the thing humans have used to sort, rank, divide, enslave, and brutalize each other for thousands of years, is, underneath every bit of it, a sunlight dial, a setting. The best estimate your bloodline ever made about how much sun you'd need shielding from, based on the latitude your people stood at, the food they ate, and a star that never once had an opinion about any of it. Light skin was never the upgrade people assumed it was. Drop it back at the equator, and it turns into a straight-up liability. DNA taking more hits, cancer risk climbing, folate cooking off in the blood. Dark skin isn't primitive or less evolved. It's the original. It's the default everyone started from. And pale is the late local edit. And that dial is still sitting on your body, still turning. Every summer your skin goes darker in the sun and fades again over winter. That's the exact same folate versus vitamin D negotiation your ancestors ran, just sped up from millennia to a few weeks. Checking the UV index on your phone before you head outside is a high-tech version of a calculation human skin has been making for over 1 million years. The vitamin D pill, people get told to swallow through a grey northern winter, exists for one reason. A body got separated from the sky it was tuned to, and somebody had to put the missing sunlight in a tablet. Even a tan line is a tiny map of the entire story. Pigment rising up exactly where the light landed and nowhere else. The freckles that come out in July, the burn after an afternoon you misjudged. That's the same machinery your ancestors lived and died by, still clocked in, still running on your back. The dark-skinned, blue-eyed man in that Somerset cave and the pale Brit walking past his glass case aren't two different stories. They're the same story, caught mid-sentence. The line Blumenbach scratched out with his shelf of skulls is younger than half the cathedrals still standing in Europe. The dark skin sitting at the root of every single human family tree, every one, no exceptions, is older than all of it. We built an entire planet's worth of hierarchy, prejudice, and bloodshed on top of what was, in the cold final accounting, a vitamin problem. Every shade walking around today is just the same handful of African ancestors working out the same problem in a different patch of light. Nobody landed on the wrong color. There was never a wrong one to land on, so here's the one to sit with. If your family has bounced around the map in the last few generations, and most families have, then your skin is almost certainly tuned for a sky you have never once lived under. Where on earth was your skin actually built for, and how far from it are you sitting right now?